Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Just Another Pure Killer, and it's by Chef of Death. And I chose it because it goes back to my roots. I used to basically do a whole bunch of killer Sudokus, killer cage Sudokus, and I don't know. I always find them fun, so it's always fun to see another killer cage Sudoku. Anyways, here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have killer, where digits in a cage sum to the given total, and digits do not repeat within a cage. So this is typical killer cage Sudoku rules. So that means, for example, these 3 digits must add up to 6, these 3 digits must add up to 10, these 3 digits must add up to 11. So as an example, you could have something like, let's see, 2, 5, and 4 here, and that would satisfy this because 2, 4, and 5 add up to 11. What you could not have is something like 3, 5, and 3. Even though this adds up to 11, we have a repeat in this cage, and that's not allowed in normal killer Sudoku rules. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so the things that are drawn to my eye are the killer cages that are 3 in size that add up to 6 and 7. The reason why is you know that there's only one set of digits that add up to that have 3 digits that are unique that add up to 6 or 7. For 6, it's 1, 2, and 3, obviously, which is the minimum you can have. And for 7, it's 1, 2, and 4, right? If you try to have any other combination of digits to add up to 7, it won't work. So we know this is specifically 1, 2, and 3. This is 1, 2, and 4. This is 1, 2, and 4. And this is 1, 2, and 3 here. Okay, so where do we go from there? We have 3. All of the killer cages are 3 in size, so that is helpful. We know that you have 3 unique digits. Okay, first of all, 1, 2, and 3 in this box have to appear in rows 1 and 2. And 1, 2, and 4 in this box have to appear in rows 1 and 2, which means in the rest of row 1 and 2, we cannot have a 1 or 2, because again, we account for 2 for 1, 1, and 1, 2 here in row 1 and 2, and we account for 1 row 1 and 1, 2 in rows. Actually, it's probably easier to look at it this way. We have a 1, 2, 3, 4 quadruple in row 2. That means there are 4 cells which require the digits 1 through 4 in those 4 cells. That means those 4 cells contain those 4 digits. So this cannot be 1 through 4 for the rest of the row. So this has to be 5 through 9. 7 cannot be here. 7 cannot be here. And this digit, if it were 8 and 9, it cannot add up with 2 other digits to add up to 10. So this is 5, 6, or 7 here. We also know in row 2, where is the 3? Because we've eliminated 1, 2, and 3, 1, 2, 3, 4 from the rest of the row. These can't be 3. This can't be 3 because it's either 1, 2, or 4. So the 3 must be here, which eliminates 3 in the rest of the box, right? So this can't be 3. Same with the 4. Where's the 4 in row 2? It has to be one of these 2 digits because there's no other place for it. Therefore, that eliminates 4 in the rest of the box. So this can't be 4. And this shows that we can't have a 1 or 2 in the rest of row 1 and 2, right? Because we see a 1, 2, 1, 2 pair here, so none of this can be 1 or 2. We see 1, 2, 3, and 1, 2, 4 here, so none of these can be 1 or 2. So this can't be 1 or 2. That means, what can this be? it can be to add up with 5, 6, or 7 to add up to 10. If you had 7, it's 1, 2, and 1, 2. But this is 3 at least. So this can never be 7. If it's 3 and 6, you can add up to with 1 to add up to 10. 3 and 5 adds up with 2 to add up to 10. You could also have 4 here. 4 and 5 adds up with 1 to add up to 10. But if you had 4, 5, and 1 here, the problem is that would eliminate 1 and 4 from these cells, which would force both of these cells to be 2. So that's not possible for that to be the case. Actually, another way of looking at it is we have a 1, 2, 4 triplet in column 5, which eliminates 1, 2, and 4 in the rest of the column. So this can't be 4 either way. So this must be a 3 here. This must be a 4 here, because we can't have a 4 in the rest of the column because of the 1, 2, 4 triplet. So this can't be a 4. That leaves this as 5 through 9 in the rest of the column. This can't be 7 because of the 7 here. Let's see, what else do we have here? It's similar here, actually. This is exactly the same. We have the exact same setup. We have a 7 here, a 7 cage here, and a 6 cage here. Well, this is a 1, 2, 3, 4 quadruplet, and then actually we have a 1, 2, 3 triple in column 8, which eliminates 1, 2, and 3 in the rest of the column. This can't be 1 or 2, so this is 4, which makes this not 4. That leaves 5 through 9 here. And again, similarly, this can't be 7, this can't be 7, so 7 has to be one of these two, and then one of these two. This can't be 8 or 9 because of the triplet. The 3 cells adding up to 10 here. We have a 3 here, which eliminates 3 here. So this again could be 3 or 4, but the 3 can only be with 1 or 2 here. And the 4 could only be with 1 or 5 specifically of the remaining digits. So this 1, 2, 1, 2 pair eliminates 1 and 2 in the rest of the row. So this is 4, which means this can't be 4. This must be then 3, because that's the only digit remaining. That leaves this as 5 through 9 also. This is 5 through 9. This can't be 7. And we have that. So these two, you can never have 5 and 6 here adding up, because the problem is that would eliminate all possibilities for this cell here. So if we try to have 5 and 6 here with 2, that doesn't work. That means the only possibility we have left for this 13 cage must be 5, 7, and 1. So this must be 5, 7, and 1, because that's the only possibility we have left here. That eliminates 5 in the rest of the row, so this is 6, which makes this a 1, which makes that 2. That makes this 1, which makes this 2. This is 5. 5, 6, and 7 are eliminated from the rest of the row. And this is a 1, 5, 7 triplet. This can't be 1 because of the 1 in the column. This can't be 5 anymore here. What's the minimum for these two digits? It's 6 and 7. And that requires a 1 to be here. And that's the minimum possible one, which is also the exact value that we need. So this can't be 6 or 7. Sorry, this has to be 6 or 7, and this has to be 1, which means 1 cannot be here. 1 is one of these digits. 1 is one of these digits. So where is the 1 in this lower left corner? Cannot be here because of the ones in the rows and columns. One of these needs to be a 1, so it can't be here. One of these needs to be 1, so it can't be here. So these are all eliminated. Therefore, whereas the 1 in this lower left box, it has to be here. Well, none of these can be 1, because this one sees both of these, and this one sees that cell. This can't be 6, this can't be 6 or 7. So this must be, without a 1, 3 unique digits adding up to 9 has to be specifically 2, 3, and 4. So this is 2. This has to be a 3, 4 pair, because 2 cannot be here because of that 2. This 2 eliminates 2 here, so this is 1. This can't be 1 or 2, so this is 3, which makes that a 2. This 1 eliminates 1 here, so that's 2 and 1. This 2 eliminates 2 here, so this is 3. This 1 eliminates 1 here, so that's 2. This is 1. None of these can be 5. None of these can be 6. This 3 eliminates 3 here, so this is 4, this is 3. This 12 cage cannot contain a 1 either, because we actually have, well, not all the ones. We have 8 ones, so we know where the last one has to be. It has to be here. And this 11 cage cannot contain a 1. So since this 11 cage cannot contain a 1, what does it have to be? It has to be 2, 3, 6 or 2, 4, 5. Those are the only options left. So either way, it requires a 2. 2 cannot be here, therefore this is 2. Again, it could be 3, 6, or 4, 5. Well, this can't be 3 or 5, so this can't be 4 or 6 correspondingly, right? Because it must be 3, 6 added together, or 4, 5. So this is 2. We have 8. No, we don't have 8 2s, but we know where the 2 has to be in column 6. Can't be here because of the 2 here. Can't be 2 here because of the 2 in the box. This 2 eliminates 2 here, and this is a 1, so this must be 2 here. We have 8 2s. We know where the last 2 has to be. It has to be here. Therefore, this 12 cage cannot contain 1 or 2. What can it be? The minimum for the without 1 or 2 is 3, 4, and 5, and that adds up to exactly 12. So we know this has to be a 3, 4, 5 triplet. Well, this can't be 5 here because of the 5, 7 pair, so where's the 5? It has to be here, which makes this a 3, 4 pair. And we now have this cage, which adds up to 22. What are the possibilities? Normally, it's 5, 8, 9 or 6, 7, 9, but we know we have a 5 in that box, so it cannot be 5, 8, 9. So this has to be 6, 7, and 9. We have a 6, 7, 9 triplet in row 8, which eliminates 6, 7, and 9 in the rest of the row. So these become 5 and 8. Whereas the 9 in row 8, it must be here, which means this cannot be 9 here. So this is a 6, 7 pair here. This 5 eliminates 5 here, so this is 7, which makes that a 5. The 7 eliminates 7 here, so this is 6. That eliminates 6 and 7 here, so this is 9, which makes this a 7. So this is 6, this is 7. And the rest should just be able to be done by just normal Sudoku. Okay. In column 2, what are the remaining digits? There are 3, 4, and 8. This cannot be 3 or 4 because of the 3, 4 pair in the box, so this must be 8. This can't be 3, so it must be 4 now, which makes this 3, which makes that a 4. 8 eliminates 8 here, so this is 9, this is 8, this is 9, this is 8. This 8 eliminates 8 here, so this is 5 and 8 here. The remaining digit in this box is 9. This can't be 5 or 8 because of the 5 or 8 in the row, so this is 9. This can't be 9. This can't be 8 or 9. This can't be 9. The 4 eliminates 4 here, so this is 6 and 3 added together to add up to 11. This can no longer be 6 or 8. This can't be 6 or 9. And this can't be 9 here. This 8 eliminates 8 here, so that's 6 or 9 here. Remaining digits in row 3 are 5, 8, and 9. This can't be 5, so this is 8 and 9. This is 5, 8, and 9 here. This remaining digit is a 6. That eliminates 6 here, so this is 8, which makes this 9. This 8 eliminates 8 here also, which makes that 7, which makes that 9, which makes that 6. This 9 eliminates 9 here. Remaining digits in this box are 5 and 6. This can't be 5 because of the 5 in the column, so this is 6, this is 5. That leaves the remaining digit here to be a 3, and the remaining digits here in column 1 are 4 and 8. This can't be 8 because of the 8 here, so this is 4. This is 8. The remaining digit in row 7 is now a 6. Remaining digits in row 9 are 4 and 5, but they could be both, so that's 4, 5. Remaining digits in this upper central box have to be 8 and 4, and this can't be 8 because of the 8 in the column, so this is 4, this is 8. That leaves these as 7 and 9, and this can't be 7 because of that 7, so this is 9, this is 7. Remaining digits in column 4 are 5 and 6. This can't be 6 because of that 6, so it's 5 and 6 here. We have 3 and 7 remaining in column 6. So this can't be 3 because of that 3, so this is 7, this is 3. This 5 eliminates 5 here, so it's 7. That leaves this as a 4. That 4 eliminates 4 here, so this is 5 and 4, which makes this a 5, because that's the only digit remaining. 5 eliminates 5 here, so this is 8, which makes that 5, which makes this 8, and this must be a 9 now. And that's how you solve it. Yeah, pretty straightforward. It does require knowledge, pretty detailed knowledge of possibilities for killer cages. But yeah, I've done so many that a lot of this is just basically second nature to me. So just seeing these makes it fairly simple. Yeah, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.